All right, to make sure everyone understands limits and derivatives and continuity, I created a small exercise to practice. We're going to solve it together. The first question says, calculate the following limits. Let's see how I want to get this set up. Okay, calculate the following limits. First of all, limit x minus 9 over radical x minus 3 as x tends towards 3. So if we just plug this in, we're gonna get, as x tends towards 9, not 3. If we just plug this in, we're gonna get 0 over 0, which is indeterminate. So we need to find another way to solve it. One thing we can do is, let's see, limit as x tends towards 9. This kind of looks like, what's it called? A minus b, a plus b equals a squared minus b squared, right? We can apply that here. So radical 3 minus 3, radical x, not radical 3. Radical x minus 3 times radical x plus 3 over radical x minus 3. So just to clarify, if you use FOIL, or this is a remarkable identity essentially, if you didn't understand why I used those values. So then we can look here, and x minus 3, radical x minus 3 over radical x minus 3 cross each other out. So we get that this is equal to the limit as x tends towards 9 of radical x plus 3, which if we replace is radical 9 plus 3, which is 3 plus 3, which is 6. So that is the answer to our first thing, 6. Second, limit as x tends towards 5, x plus 25 over x minus 5. So let's see. Let's write this out. Limit as x tends towards 5, x plus 25 over x minus 5. What the heck? I do not know how to write today. Okay, as x tends towards 5, if we replace, we get that this is equal to 30 over 0, which any number over 0 is equal to infinity. Any number over 0 is equal to infinity. Don't forget that. Part C, or D, I guess. Limit as x tends towards infinity, the square root of x squared plus 3x minus 2, all of it minus x. So this one is a bit more complex. So let's write it out and see what we can figure out from it. The limit as x tends towards infinity of x squared plus 3x minus 2 minus x. There we go. So if we replace it, just looking at this, we can tell that it's going to give us essentially infinity minus infinity. That's going to be what we have. So we need to figure out a way to solve this. We can try and turn this maybe into this form, because then we can FOIL and continue normally. So the way to do that, so essentially what we want to do, we want to multiply this or divide this by a number that isn't going to change what this is equal to, right? We need something that's not going to change the expression. So masalan, we need to multiply it by 1 or divide it by 1 or something along the lines of that. The only way to multiply it by 1 is to multiply it by a number over itself. So one thing we can do is to try and cancel all of this out, is to multiply it by, so let's say this is a minus b, right? We want to multiply it by a plus b over a plus b. So we're going to multiply this by x squared plus 3x minus 2 plus x over root x squared plus 3x minus 2 plus x. So you can cancel this out and it'll be the same as this, so it does not matter that we added that, in the sense of the value of the expression hasn't changed. However, this is now solvable. See, this is a remarkable identity right here, right? Plus minus. So we can expand, let me just write this out, limit as x tends towards infinity of this square, so this squared is going to be x squared plus 3x minus 2. And then x squared is, x squared is x squared, so minus x squared over, this stays the same. Let's see, x squared plus 3x minus 2 plus x, right? Wait just 1 minute. So what we can do, we can continue solving in this expression. 1 minute. Just trying to make sure I have the answer somewhere. Just so I can make sure I get the right answer. But I cannot seem to find it. It's okay. Oh wait, this is no, it's not derivatives. There it is. Okay. Just making sure that I do this right. Okay. So this is equal to, first of all, obviously the x squared by x squared can be crossed out. So we have limit as x tends towards infinity of 3x minus 2 over, I'm not going to rewrite this because it doesn't really matter right now. But one thing we can do, we can take x common from all of these, can't we? So as x tends towards infinity, or we're essentially taking the highest power, which is x into 3 minus 2 over x over. Okay, so x squared, root x squared, if we take it out, if we take an x out of it, it's just going to be 1, right? So x into 1, root 3x, when x is taken out, is going to be 3 over x. Because if we multiply x inside, it's going to be x squared. Don't forget. So if we multiply, let me just write that out. If we have, okay, let me finish this and then we can figure it out. So minus 2 is going to be minus 2 over x squared. And then plus x, obviously we can just take that as plus 1. So let me just explain how this worked in case you're not clear about it. X into root 1 plus 3 over x minus 2 over x squared plus 1, right? So if you multiply it, so x into the root is going to become x squared. So you're going to get x squared plus 3x squared over x, which is 3x, minus 2x squared over x squared, which is going to be equal to 2. So it's all going to come back to how it was originally, in case you were unclear on the math of that. So now what we can do, we can continue by crossing the x's out. We're going to have limit as x tends towards infinity of 3 minus 2 over x over, let's see, root 1 plus 3 over x minus 2 over x squared plus 1. Now we can replace x in this, and we'll get 3 minus 2 over infinity, which is 0. So 3 minus 0 over root of 1 plus 3 over infinity is 0, minus 2 over infinity squared is 0. So 1 plus 0 minus 0, so 1. So then root 1 plus 1, which is 1 plus 1. So we're going to have 3 over 2. And that is our answer. Next question. Study the continuity of f such that f of x is equal to this expression right here, where x is less than or equal to 0, and 5x, and it's equal to 5x plus 2 when x is greater than 0. So at x equals 0, obviously we're talking. So reminder, something is continuous if the limit of f of x exists as x tends towards 0 in this case, if the limit of f of a is defined, and if the limit of f of x as x tends towards a, which in this case is 0, is equal to the limit of f of a. Let me just write this out so it's more clear. F of x minus 2 over x plus 5, and 5x minus, why are these all 5s and 2s? Where x is less than or equal to 0, x is greater than 0, at x equals 0. Okay, So first of all, we need to start by finding that the limit as x tends towards a, which in this case is 0 of f of x, exists. How do we find that? We need to find so the limit f of x as x tends towards 0 minus exists, and limit f of x, make sure you guys can see, as x tends towards 0 plus exists. So 0 minus means a little bit less than 0. Which of these two expressions includes x is less than 0? X is less than or equal to 0 here, which means we need to plug 0 minus into this equation right here to find the limit. So this is going to be equal to, let's see, 0 minus 2 is minus 2 over 0 plus 5 is 5. So the limit is minus 2 over 5. Now, the limit of f of x as x tends towards 0 plus is you're just gonna, so 0 plus first of all means it needs to be a bit higher than 0, which is true in this case. So you plug it into this expression, which is going to be equal to, okay, so 5 times 0 is 0, minus 2 is going to stay minus 2. So first of all, does the limit of f of x as x tends towards 0 exist? No, because minus 2 over 5 is not equal to minus 2. Now, obviously we can say that it's not continuous from here on out, like we don't have to continue. However, I'm going to continue just to explain a little something else to you guys. So we also, f of a needs to be defined. So f of a is f of x when x is this number right here. This is a. So f of a is f of 0. So we need to check if it's even possible to have an equation where 0 is substitutable. So if you look at this equation here, we can see that x is greater than 0. If it's greater than 0, that means it can't be 0. However, if you look here, you see that it says x is less than or equal to 0, which means we have a possibility for x to be equal to 0. So f of 0, which equation do we need to plug 0 into? This one, because this one right here is the one where 0 is even possible to be replaced. Like it's the only place where you can even add in a 0. If you add in 0, it's going to be minus 2 over 5. Now, moving on to the next question, derivatives. Find the derivative of these 5 equations. We're going to start, let's see, with the very first one. Find the derivative of f of x being equal to x power 3 over 4 plus x power 2 over 9 plus x over 2 plus 7. So the way to solve this is to solve each individual term as a derivative. Let's see. Okay, so x power, so let's solve this as u over, I just ripped out a paper to make this easier. We're going to solve this kind of a long way, which is u prime v minus v prime u over v squared, right? So for x 3 over 4, u is equal to x3, v is equal to 4, u prime is equal to 3x2, v prime is equal to 0. So we can just plug this in. We're going to say that it's equal to u prime, which is 3x squared times 0 minus, no, wait, did I do that in reverse? No, times 4, not 0, sorry. Times 4 minus x3 times 0 over v squared, so 4 squared. Plus, and then we're going to do the same thing for the rest of these. Let me just figure that out really quick. So we've got x squared over 9 u is equal to x squared, v is equal to 9, u prime is equal to 2x, v prime is equal to 0. So plus u prime, which is 2x, times v, which is 9, minus u, which is x squared, times v prime, which is 0, over v squared, so 9 squared. X over 2, same thing. U is equal to x, v is equal to 2, u prime is equal to 1, v prime is equal to 0. So plus u prime v, so 1 times 2, minus v prime u, so 0 times x, over v squared, which is 2 squared, plus the derivative of a constant number is always 0, so plus 0. Then we can solve this really quick. We get, let's see, 12x squared over 4 squared is, 4 times 4 is 16, plus 18x over 9 squared is 81, plus, let's see, 2 over 4, which is equal to, and divide by 4, we get 3x squared over 4, plus, divide by 9, 2x over 9, divide by 2, plus 1 over 2. And that is the derivative of the first equation. There is a faster way to solve this, but I solved this the long way just so that everyone understands it completely. Next derivative. Find the derivative of this. This is solved essentially the same way as the other one, just it's not as long. So f of x is equal to x squared plus 4 over x minus 3. F prime of x is equal to u prime v minus v prime u over v squared. U is x squared plus 4. V is x minus 3. U prime is 2x. V prime is 1. So the derivative is u prime, which is 2x, times v, which is x minus 3, minus v prime, which is 1, times u, which is x squared plus 4, over v squared. V squared is going to be x minus 3 squared. So 2x times x is 2x squared. 2x times negative 3 is minus 6x. Minus 1 times x squared is minus x squared. Minus 1 times 4 is minus 4, over x squared minus 6x plus 9. I don't actually need to expand on that. You can just keep x minus 3 squared. So we can just finish expanding that. We're gonna get that the derivative of this equation right here is x squared minus 6x minus 4 over x minus 3 squared. Next, 9x minus 4, all of it power 3. We need to find the derivative of that. Let's write it out. The function f of x is equal to 9x minus 4, all of it, cubed. The derivative of that, we just got to find, so we move 3 down. So it's going to be 3 into 9x minus 4, all of it squared, because obviously 3 minus 1 is 2. And then I'm 90% sure, I'm just going to make sure of this. It is, yeah, you then multiply it by the derivative of this in here. So times the derivative of 9x minus 4 is 9. So all that times 9. So 3 into 9x, all of it squared is 81x squared. 8 times 9 is 6, wait, what? 8 times 9 is 72, right? Yeah, 72x, and then 4 squared is 16 times 9. So you don't need to expand that, but you can continue from there if you wanted. So that's the derivative of this. Next, Derivative of 2 root x. This is quite easy, of 2 root x. So the derivative of that is 2 times x power 1 over 2. Because remember, root x is equal to x power 1 over 2. Then we can just continue solving this normally. So 2x 1 over 2 means we multiply that by 1 over 2. So 2 over 2 is 1, x, and then 1 over 2 minus 1. So the answer is x power minus 1 over 2. That is our derivative. The final derivative is find the derivative of f of x is equal to 3 times x power minus 4. So f of x is, can you guys still see? No. There we go. F of x is equal to 3 times x power minus 4. The derivative of that, 3 times minus 4 is minus 12. X minus 4 minus 1 is minus 5. There you go. Moving on to the probably more difficult exercise, which is this chunk right here. Take a minute, read it. If you want to try and solve it, feel free to. All right, now that if you've solved it, good job. If not, then feel free to work on it with me. So they gave us the function f of x is equal to minus x plus 4 over x minus 3. First of all, we need to find the domain. The domain of definition of this function is x belongs to all real roots except for 3, because if you plug 3 in here, it's going to be over 0, and we want it to be defined, so we can't have that. The next question is telling us to limit f of x as x tends towards positive or negative infinity. So limit f of x as x tends towards plus minus infinity. So what we have here is, if we plug it in immediately, we're just going to get infinity over infinity, which is indeterminate. So we need to take the highest power over the highest power, which is minus x over x, which is equal to 1. Sorry, minus 1. Limit, the next part of the question is limit f of x as x tends towards 3 plus. So as x tends towards 3 plus, which is just a little bit over 3, we're going to get minus 3 plus 4 is going to be minus 1 over infinity, which is equal to 0. And then limit f of x as x tends towards 3 minus, which is this next question right here. We're going to just do the same thing. It's going to be minus 1 over infinity. No, plus 1 over infinity, right? Yeah, plus 1 over infinity, which is 0. Next question. Deduce the vertical asymptote and the horizontal asymptote if possible. Now, the vertical asymptote is essentially, if you have a graph, what x value is it never going to touch? And the horizontal asymptote is essentially what y value it's never going to touch. To figure that out, what we need to do is look at the limits that we just found. Oh, wait, okay, pause. I just made a really silly mistake. 3 minus 3 is not infinity, it's 0. So 1 over 0 is infinity. Again, here, same thing, it's 0. So then this is infinity. There we go. That makes it better. So what we need to find is, as x tends towards infinity, what is y? And as y tends towards infinity or is equal to infinity, what is x? Essentially, what that means is, when x is infinity, which is all the way over here, what is y? In this case, when x is infinity, y is minus 1, right? When x equals infinity, when y equals infinity, x is 3-ish, right? Which means when x and y are equal to infinity, whatever value you have here, that should be an x, whatever value you have here, those are the asymptotes. So x equals 3 is going to be the vertical asymptote, because when x can never be equal to 3. And then the horizontal asymptote is going to be y equals minus 1, because it can never touch -1. So there you go. That's the vertical and horizontal asymptotes. The next question says, find the x-intercept and the y-intercept. So this is part D. X-intercept is when y equals 0. So when y equals 0, minus x plus 4 over x minus 3 is equal to 0. So minus x plus 4 equals 0, x equals 4. So the coordinates of the x-intercept are x equals, 4, 0. Y-intercept says x equals 0. When x equals 0, we have 4 over minus 3. So y equals 4 over -3. So the coordinates of the y-intercept are 0, 4 over 3, or -4 over 3. There you have the x and y intercept. The next question is find the derivative of this equation and the table of variations. So we're going to start with the derivative. F of x is equal to minus x plus 4 over x minus 3. U is equal to minus x plus 4. V is equal to x minus 3. I'm assuming at this point in the video I don't need to explain what I'm doing. If you're not understanding what I'm doing, either go back and rewatch this video or watch my video explaining the basics of derivatives. U prime is equal to minus 1. V prime is equal to 1. Is that right? Yeah. I did not realize I made that exercise like that. Anyways, so the derivative of this function is going to be u prime, which is minus 1, times v, which is x minus 3, minus v prime, which is 1, times u, which is minus x plus 4, over v squared, which is x minus 3 squared. So we can just fill that out. We're going to get minus x plus 3 plus x minus 4 over x minus 3 squared. So the derivative is minus 1 over x minus 3 squared. So now what we need to do, we need to follow the golden rule to find the critical points, which is to find where it increases or where it changes from increasing to decreasing or decreasing to increasing. How do we do that? We set it equal to 0. So in this case, minus 1 is never equal to 0, so there's no critical points. Now, table of variations, which is the next part of the question that they asked us. So x, f prime of x, and f of x. Let's figure out what values we need to put in here. Obviously minus infinity and infinity. But didn't we say that our vertical asymptote is x equals 3, which means we're not allowed to put anything on x equals 3? Meaning for the table of variations, we should probably put the 3 in there and block it off like that. Let's take a number less than 3 to figure out if it's positive or negative. Easiest one is to take 0. So plug 0 into the derivative right here, which is this number that we got. So minus 1 over x minus 3, all of it squared. If we replace the x with a 0, we'll get 1 minus 1 over 9, which is a negative number, right? Minus 1 over 9? Yeah, that's a negative number. We can take a number larger, but we also know that there's no critical points, which means it doesn't change direction. So we can just put it minus as well. Now, because they're both minus, that means it's decreasing in both cases. However, where is it decreasing from and where is it going to? That, we can go back to look at the limits. Where did I write that? Right here. So when x is minus infinity, it's going to be at minus 1, right? Minus 1. when x reaches infinity, it's also going to be at minus 1. Now, when x is at a little bit less than 3, right? We're talking a little bit less than 3. So 3 minus, how is it decreasing? Did I do something wrong? 1 second. Because there's no way that's possible. One second, let me try and figure this out. All right, I figured it out. So because it's 3 minus, it needs to be minus infinity, not plus infinity. And because it's 3 plus, it's plus infinity. So it decreases from minus 1. So 3 minus is equal to minus infinity. So it decreases from minus 1 to minus infinity. And then it decreases from infinity to minus 1. Next question is draw. That is going to be pretty easy. Let's see. Do I have a ruler right in front of me? No, I don't, but that's okay. So what part is this? This is part F. We're going to go all the way down. Assume I know how to draw this because I clearly don't. And then we're going to have this be the graph. Now, remind us what our asymptotes were. Y equals minus 1, so it's never going to hit y equals minus 1. So on minus 1, we can put a dotted line. And then our vertical asymptote is x equals 3, so it's never going to hit 3. So 1, 2, 3, that's right here. We can put another dotted line. So now, at x equals minus infinity, it's going to decrease from minus 1 to minus infinity, which means it's going to go, oh, right, we can take, 1 second, we can take our x-intercept as 4, 0, so 1, 2, 3, 4, so it's going to hit right here at some point, and our y-intercept is 0 minus 4 over 3. So we're going to take that as, let's say, right around here, right? Yeah. So essentially, our graph needs to pass through this. So it's going to decrease from minus 1 minus. It's not quite going to hit minus 1 to minus infinity. And it has to pass through this dot. So we can draw it like that. And then it's going to decrease from infinity, which is all the way up here, to just above minus 1. And it has to pass through this dot right here. So there you go. We just drew a graph out of a function that we knew nothing about. The last question says, deduce the equation of the tangent to this curve at x equals 2. If you guys remember from watching my video on derivatives, to find the equation of a tangent to a curve, we apply the formula y minus f of a is equal to f prime of a into x minus a. In this case, a equals 2. So y minus f of 2 is equal to the derivative of 2 into x minus 2. So we essentially need to plug these in really quickly. We have, so let me just figure this out really quickly. F of 2, we replace it into this, which is minus x plus 4 over x minus 3 because that's just the function. So minus 2, so 2 over minus 1, right? 2 over minus 1, so minus 2. So y minus minus 2. And then the derivative that we had, let me just remind myself of it, was minus 1 over x minus 3 squared. So we plug 2 into this, we get minus 1, minus 1 squared is 1, so minus 1 over 1. So minus 1 over 1 is minus 1 into x minus 2. So y equals minus x, and then plus 2 minus 2, 0. So the equation of the tangent to this curve at x equals 2 is y equals negative x. And that is our exercise of the day.